The James Webb Space Telescope offers scientists an unprecedented view of the universe, delivering amazing findings that continue to thrill the scientific world. And it has done it again. In a recent effort, researchers directed the Webb telescope toward the remarkable Whirlpool Galaxy M51 and discovered intricate details of the empty cavities and glowing filaments in the galaxy's expanding spiral arms. Although it might not sound like a phenomenal discovery, this is the picture scientists have been waiting for. This just-released mesmerizing image allows us to peer inside a spiral galaxy that lies some 27 million light-years from our planet. The dark red regions trace the filamentous warm dust that permeates the middle of the galaxy. The red regions show the reprocessed light from complex molecules that form in the dust grains, while the orange and yellow colors reveal the regions of ionized gas from the newly formed star clusters. Using two of its most powerful instruments, the near-infrared camera, NIRCam, and the mid-infrared instrument, MIRI, the James Webb Telescope has given us two perspectives of the celestial object. Both devices are designed to capture the distant universe by decoding infrared light signals emanating from distant stars and galaxies. Measuring 27 million light-years from Earth, the James Webb Telescope image is one of a series of observations aimed at shedding light on the interplay between stellar feedback and star formation in environments outside our own galaxy, the Milky Way. First discovered in 1773 by French astronomer Charles Messier, the Whirlpool Galaxy, also known as M51, is one of the best-known objects in the night sky and is part of the Messier catalog. M51 is called a whirlpool because of its spinning structure, similar to water around a drain. It lies 27 million light-years away in the constellation Canes Venatici. So the image we're looking at is of the Whirlpool Galaxy as it was 27 million years ago. But never before have we seen an image like the one captured by the James Webb Space Telescope, the most powerful of its kind. This new image not only represents a journey through space, but also a journey back in time. Stellar feedback has a dramatic effect in the middle of the galaxy, creating a complex network of glowing knots and cavernous bubbles, according to the European Space Agency, which helped build the telescope and launched it into space last year from its spaceport on the French Guiana. Stellar feedback is the term used to describe the energy output of stars and the environments that generate them, and is an important mechanism for influencing star formation rates. According to the agency, understanding stellar feedback is critical to developing accurate universal models of star formation. The whirlpool has a little brother, whose gravitational effect is assumed to be partly responsible for the galaxy's distinctive well-developed spiral arms. When Hubble captured an image of M51 more than a decade ago, the team behind it said they couldn't wait to see the same image with the planned James Webb Telescope. This observation of M51 is part of a series titled Feedback in Emerging Extragalactic Star Clusters, called FEAST. And that is what James has achieved with his discovery of the Ring Nebula with his advanced suite of infrared sensors. James Webb managed to obtain images that provide unprecedented spatial resolution and spectral sensitivity in all that cosmic chaos. According to the ESA statement, what this means is that the Space Telescope, which is located about 1 million miles, 1.6 million kilometers, from Earth, was able to reveal details about the intricate structure of the Ring Nebula that scientists simply hadn't seen before. When we first saw the images, we were blown away by the amount of detail in them. The bright ring for which the nebula is named is made up of about 20,000 individual clumps of dense molecular hydrogen gas, each as massive as Earth. Within the ring, there is a narrow band of emission from polycyclic aromatic hydrocarbons, or PAHs, complex carbon-rich molecules that we would not expect to form in the Ring Nebula. Outside the bright ring, we see curious spikes pointing directly away from the central star that are prominent in the infrared but barely visible in Hubble Space Telescope images. We think this could be due to molecules that can form in the shadows of the denser parts of the ring. where they are shielded from the direct intense radiation of the hot central star. For example, by capturing wavelengths of infrared light emitted by the nebula, also known as wavelengths of light invisible to the human eye. The James Webb revealed information about the filamentary structure of the inner rings, as well as approximately 10 concentric arcs in the outer regions of the phenomenon. These bullseye-shaped features really surprised. These rings must have formed roughly every 280 years as the central star shed its outer layers. When a single star evolves into a planetary nebula, there is no process that we know of that takes that kind of time frame. Instead, these rings suggest that there must be a companion star in the system, orbiting at a similar distance to Pluto from our Sun. As the dying star shed its atmosphere, the companion star shaped the outflow and sculpted it, offering this explanation. It's also important to note that this isn't the first time that the James Webb has turned its hexagonal golden eyes at the Ring Nebula. Very recently, the machine captured this portion of the universe in high resolution, and scientists added green and purple filters to create a glorious scene for us to admire. The history of observing the Ring Nebula means more than its physical components. It is a symbol of human curiosity and advancement. From the early misconceptions that led to its labeling of a planetary nebula to the advanced technology of James Webb, our quest to understand this phenomenon reflects the growth of astronomical science itself. The Ring Nebula was discovered in 1779 by astronomers Antoine Darquier de Pellepux, Charles Messier, and was added to the Messier catalogue. They found it while trying to track a comet through the constellation Lyra. Today, the Ring Nebula stands as a symbol of astronomical archaeology. The colorful main ring, the remains of a dying star on its way to becoming a white dwarf, is a vivid reminder of our cosmic connection. By studying the nebula, we are not just looking at a distant object, but we are looking into the past, present, and future of the universe itself. Our own sun may have a nebula when it finally expires in about 5 billion years, and it will become a white dwarf, although we almost certainly won't be here to see it. It may seem strange that two different images of the same nebula would have such different colors, but Webb observes objects at infrared wavelengths, which means our eyes literally can't handle Webb's raw images. The data from the Webb images simply appears black before Webb's image processors translate the infrared data into visible wavelengths of light, which they did with the image to highlight certain aspects of the nebula in each image. From some of the deepest views of the universe to studying the rings of planets in our own solar system, Webb is offering astronomers a whole new view of space. What discovery do you expect next from the Webb?